Hi, everyone. It's 3:10, so we'll get started. Welcome back to the Responsible Conduct of Research seminar series. Our topic today is research misconduct and its impact on careers in science. Our lecturer is Dr. Prescott Deininger. He received an AB in chemistry from the University of California at Santa Cruz and a PhD from UC Davis. His graduate work concentrated on the sequence organization of the human genome. He was a postdoc at UC San Diego, where he worked on sequencing the polyoma genome. He later was a NATO fellow at the Medical Research Laboratory of Molecular Biology in Cambridge, England, where he worked with Dr. Frederick Sanger, who won 2 Nobel Prizes in chemistry and invented DNA sequencing. While working in Cambridge, Dr. Deininger invented the procedure currently in use for shotgun sequencing of genomes. Here at Tulane, Dr. Deininger is the Joe W. and Dorothy Brown Chair in Oncology, Professor of Epidemiology at the School of Public Health and Tropical Medicine, and Director of the Tulane Cancer Center. He also serves as the co-director of the Louisiana Cancer Research Consortium and is the founding director of the Laboratory of Molecular Genetics at the Ochsner Medical Foundation. Dr. Deininger is a fellow of the American Association for the Advancement of Science. He has served as a journal editor on numerous editorial boards and as a grant reviewer for the NIH, the NSF, and the Department of Defense. He has published more than 100 papers on the subject of the human genome. We're delighted to have him with us today. I ask that you please welcome him. And he has asked that you please turn on your video so that he can see you during his presentation. Dr. Deininger?
Thank you very much. I don't need to see everybody. You know, if you're wearing your underwear or something like that, it's probably best to keep the camera off. But it just helps me to see a few faces out there as I'm talking to you. And I also want to mention that really the only reason I give this lecture is to listen to Lisa say all these nice things about me. I should also mention that the bones of this lecture were provided to me. They were given last year by Dr. Bunnell, and I'm sure that Lisa and Brian had some input in how it was set up. So what I've tried to do is add a few things that I think are particularly important and or timely for what we're doing right now, for where we are in science. Let's see if there we go. So this is just a quote about how important integrity in science is. And I can't stress that what we're going to be showing you is that if people don't trust scientists, then science is in a lot of trouble in our country. And so it's really important that we show a high level of integrity. And there are some serious consequences if you don't show a high level of integrity. So first question here is a faculty member at University of Vermont College of Medicine admits falsifying data in 17 grants to NIH and fabricating data in 10 publications over a 10-year period. So these everything I'm going to show you are real life situations, okay? And so is this research misconduct? I think this was originally done as a question answer thing. We're not really set up for that. I think most of you can see that that is definitely an example of research misconduct. You're not allowed to falsify data in any way. The end result is this particular investigator, whose name is out there, Dr. Eric Pullman, was banned forever from receiving public research money. That would be a real blow to a career. He had to retract all 10 of those papers. He actually got a prison sentence. Okay, so there's consequences for the individual that go beyond your individual career. And he had to pay back $180,000 of grant money. Okay, so it can be pretty bad. Here's the next one. A faculty member provides a hypothesis regarding visual working memory to a student who conducts the research funded by National Institute of Mental Health. using NIH grants. The student gets results that are in line with the hypothesis, but the data he has involves some outliers. The student removes those outliers before presenting them to, and the research is eventually published. So when you just removing part of your data, which is then published in 4 journals, is that fraud? Or is that misconduct? And the answer is, yes, it is. Okay. It's a little bit different than making up data. In this case, he's just massaging the data. But anything that changes the way your data is construed and its interpretation is misconduct. This particular graduate student, note here, it was not the PI of the grant who came up with the idea that was held responsible. It was the student who did the work and actually who removed those data before the PI saw them. He was found to have engaged in research misconduct. 4 papers were retracted and or corrected. Well, actually, I don't have anything more on that one, except that you can see that if something like this happens, it's going to be really hard to get good jobs moving forward that involve a lot of research. So what we really want to make sure is that you're learning how to do good science, good ethical science, and not how to officially do fraud. Okay, so today I'm going to talk about some of the background and the concept and the issues surrounding research misconduct. We'll go through some cases, a couple that Bruce had and a few more that I just added yesterday. And then we'll go through some of the nuts and bolts that regard how Tulane handles such things and how you should handle things if you're ever exposed to something like this. So many of you may not realize that prior to, say, 1950 or so, there was very little federal money going into research, okay? That's grown tremendously over the past 4, 5, 6 decades. And as it's grown, the public has become more and more cognizant of this investment they're making. And so they've been making many more thoughts about making sure that it's done ethically. So about 1/3 of all research and development is funded by the government, and about half of all basic research is funded by the government. And obviously, the government and the voters and everybody else is starting to pay more and more attention as they invest more and more money into this enterprise. So it wasn't until the 1980s that they did a sort of a fundamental law concerning research misconduct. And prior to this, each institution handled it on their own. And there were actually examples of institutions sort of wanting to suppress these. If you think about it, it's not good for a institution's reputation to be found to be doing misconduct in research. But what I'll tell you that I've found over many years and exposure to some of these incidents, it's way worse to be caught trying to cover up. You know, the cover up is often worse than the actual initial crime. And so if I could tell you anything, is that if anything comes up having to do with misconduct, the best thing to do is to attack it immediately, to be open about it, to get people involved, and solve it quickly. And in December of 2000, the Office of Science and Technology Policy adopted a federal policy on research misconduct. So that's only 20 years. And the formal policy on that you can look at if you want to look at that. And so basically any institution receiving public health service funding, so pretty much any major institution involved in research, including some companies, have to follow these rules. And it covers any entity that applies for a research training, or research-related grant from the Public Health Service. And it establishes the definitions for what is research misconduct. It outlines procedures for reporting and investigating misconduct at all levels, both at the institution and nationally. And it provides protection for whistleblowers and persons accused of misconduct both. So the important thing is there are times when people are accused of misconduct where it's not actually misconduct, or it's not as bad as the accusations make it. And so it's very important that both the accusers and those who are accused are protected maximally as we go through this process. So institutional procedures, there's a research integrity officer who is supposed to receive and investigate allegations of misconduct. In this case, it's our Senior Vice President for Research, Giovanni Piemonte, who is ably helped by the Office Tulane Research Compliance Office, Lisa and Brian, who are running this course. And so basically, if somebody makes an accusation at any level, for instance, if an accusation came to me as a Tulane employee, as a faculty member, or came to a department head, or me as a cancer center director, or is made directly to Lisa or Brian, they have to start some sort of initial process to find out, to take a look at whether there's any kind of potential merit behind the allegation. And if there seems to be any merit, they have to set up a formal investigation involving a committee, usually involving faculty and researchers, who will go through it. And they'll set somebody in charge of adjudicating the investigation. And then eventually because this is almost all done with federal money, this is all done in along with the Office of Research Integrity at the NIH, so that the findings have to be passed through them. And that office actually has the final say on much of this sort of thing. Okay, so they develop the policies and procedures. They go ahead and monitor any of these misconduct investigations. And basically, once the institution has done their investigation, they will send their recommendations to the ORI. But the ORI will decide whether they felt like the right conclusions, or whether the investigation was done in a rigorous way. The ORI will help the institution do things, will actually help implement activities and programs to teach responsible conduct of research. Some of the parts that came into this lecture come from the Office of Research Integrity websites. They'll do policy analysis and so on. And then they'll also administer some programs for maintaining the institutional assurances and responding to allegations of retaliation against whistleblowers to protect the whistleblower. So it's just their job is to make sure that we're being good citizens in our professional life, and that researchers who conduct and report their work honestly, accurately, efficiently, and objectively can achieve research career. I'm blanking out on what my RCR is. But anyway, can achieve enlightenment. Okay, so when it comes to misconduct, there is really zero tolerance for misconduct. You have to protect the whistleblowers. They worked on how to clarify how to report things. There's actually efforts to train mentors, especially if they've ever gone south. and to model ethical behavior. And of course, one of the things that's grown out of this is courses like this one you're dealing with now, so that students and trainees are always exposed to some of the rules. So what is research misconduct? Okay, it involves a bunch of things. Fabrication of data, that's just completely making up data. That's I think everybody can easily see that's a no-no. Falsifying data, meaning that guy who pulled out those outliers or just massaged their data a little bit, that's still falsifying. And I think you've already had lectures involving data integrity and so on, and how to make figures. Anything where you manipulate your data in a way that makes it show better than it should is a falsification. And plagiarism. And plagiarism, we're going to talk about some side issues there in a minute. But obviously, plagiarism is copying somebody else's data. It can also be double publishing and publishing your same stuff multiple times. In any kind of grants, performing, or in reviewing research results. So fabrication is making up data, falsification, distorting data. And then we have this whole group of other research practices that are, which involve, say, plagiarism, but also involve, I'm going to bring up conflicts of interest. Okay, it's very, very important that we always avoid any vision that we might be biased in some way in how we present things. And so any kind of misuse of your data is included there. I think we've sort of covered this. Fabrication is making up results. Falsification is manipulating the data so it doesn't accurately represent the record. Okay, so that would be an example if you have a figure and you do something to enhance the bands in a way that's not kosher, which is not linear, okay, where you enhance one band at the expense of other bands and things like that. And of course, taking anyone's ideas, processes, results, or words without proper credit. And there's a lot of opportunities or places where you can get in trouble involving this. So criteria involve a significant departure from accepted practices. So you're in a lab now trying to learn what are the accepted practices for doing research. And you can't deviate from significantly from standard practices in research. And it needs to be committed intentionally, knowingly, or recklessly. So this separates, there's misconduct and there's bad science. And sometimes they come to the same point. But doing bad science is not considered misconduct. It's still something you really want to avoid. It's not good for your career to do bad science and to be represented for bad science. But if you're doing it just because you don't know enough about the techniques you're using or something like that, and it's not reckless or intentional, then it's not misconduct. And of course, there has to be evidence. And these pictures, I think, are referring to one of the classic examples where somebody shaved a bunch of mice and was trying to look for skin cancer, and he drew on with a little marker. He drew marks on the skin and took pictures and said, "Oh, I get cancer." Okay, so that's a deliberate falsification of data. It does not include honest error, misinterpretation of results, or differences of opinion. Okay, so if you mess up your statistics and your conclusions aren't truly significant, if you honestly went at it, it's not misconduct. But I don't recommend messing up your statistics. It's still good to learn how to do your science well. Okay, so the top bad behaviors: fabricating or cooking research data, ignoring major aspects of human subject requirements or other oversight type things. This is one that actually comes up a fair amount, probably more, is not properly disclosing involvement in firms whose products are based on one's own research. There's been a number of high-profile cases where somebody presented data that made a drug say look good, and then you find out that the guy owns some rights in the company that had the drug. That's a no-no. Relationships with students, research subjects, and clients that may be interpreted as questionable. Anything where you try to manipulate research subjects or students to give the kind of data you'd like rather than anything else. Using another idea without obtaining permission or giving due credit. There are a lot of really striking examples of plagiarism out there. Unauthorized use of confidential information in connection with one's own research. This would be the idea of, well, you've occasionally heard of one lab using somebody else's lab's data or data from a student who in one lab being used by another lab or whatever. Failing to present data that contradict one's own previous research. Okay, so anytime you selectively present your data to make sure it goes in a particular way. Overlooking others' use of flawed data or questionable interpretation of data. You know, if you see that something's wrong, even if it is useful for you, you ought to not use it. Changing the design methodology or results of a study in response to pressure from a funding source. There's been a lot of fuss over things like tobacco companies funding cancer research and whether they ever put undue influence. Actually, another one might be, say, a particular individual who's facing an election and might want a vaccine approved and might put undue pressure. And obviously, publishing the same data or results in 2 or more publications is a no-no. So there's a paper on the misconduct accounts for the majority of retracted scientific publications. So in this paper, a couple things that I find interesting. One is retractions are going up. Okay. Now, is that better oversight or is that more fraud? Maybe a little bit of both. So year of retraction, you note this paper's a little bit old, but I expect it's gone up because, and you know, different countries, you know, US has a lot of it, but we also have been a huge source of publications. So you note that plagiarism is more common in some countries, or duplicate publication. So there are some cultural and or different pressures in different parts of the world that influence which type of misconduct might come up in various countries. I did want to mention in terms of plagiarism, just so you know, out there are a lot of tools out there to catch plagiarism these days. Every editor has available something like Authenticate. This is the one Elsevier that I've been an editor for uses. And it will search the internet for any publication or anything else that uses a lot of words. And actually, I didn't have a better one than this to show you, but if I run a paper through there, every paper, it'll find things. Sometimes it'll find 3 words in a row that match somewhere. But so what you have to do is look for the percent of the match to say, how bad is it? Or how big a block of a match it is. But you know, you can be caught for just reusing the same paragraph in a couple different papers. Okay, it's okay to put the same ideas out there, but you really have to write them fresh. What you will find though is if I write about my field fresh, there will be little patterns of words that come out all the time, and that's okay. I just have to make sure that I'm really doing it independently. So fabrication. Worst is creating data for experiments that were never done. making up extra subjects, more mice, more humans. This is a common one, putting different images to represent together from different places and pretending they're from a single experiment. Being obviously changing brightness or contrast of an image in a way that is not acceptable. There are ways you can do that, but you have to do it to everything evenly. And any change that conceals information, even when it's considered not specific. And of course, showing only a very small part of your data and hiding information that would maybe make that data not look so good is even considered an example of fabrication. Falsification would be swapping around one subject record for another, inflating the number of samples, taking out a few data points, again, altering images to make them appear a little bit better, or using the same anytime. There's fine lines between fabrication and falsification. Okay, there's different levels. I added this one because I pulled it out of a particular site on misconduct, because an awful lot of misconduct has to do with publications. So obviously, misappropriation of ideas, giving the wrong credit, taking somebody's idea who first said it and not giving credit for it, plagiarism, self-plagiarism. This is what I wanted to bring up, impropriety of authorship. I think you're covering publications maybe next. There are rules for why somebody's an author. And I'll tell you that there are some countries where people pay to become an author on a paper, and they have nothing to do with the work on that paper. And it all has to do with the kind of pressure, because being on a paper can make somebody's career in some cases, okay? Failure to comply with regulatory requirements, the standard violation of accepted research practices, falsification of data we covered many times. Failure to support research validation. So this is an important thing. It's your job when you publish a paper to save your data and to make it available for validation. And it's actually, if you can't do that, it's misconduct. And then if it's found in any way that your data wasn't quite right and you don't retract it, that's also misconduct. Any inappropriate response to suspected misconduct is misconduct. Okay, so why do we have misconduct? I mean, we're all bright scientists who have all kinds of great ideas, and there's really no need for us to do this. But there are times when there's just a lot of career pressure that people feel, and they feel like they either have to publish or perish. When I got my first job as an assistant professor, my department head gave me a pencil, because we still wrote with pencils in those days. And it said publish or perish on the pencil, okay? Any time a desire to get ahead, to make money, to get promoted, to get that big high profile paper, there's a lot of pressure. If you happen to be really lazy, it's easier to make up data sometimes than to do experiments. I hope that's not one that comes up too these days, because of electronics. There's a lot of ways you can fabricate data that you couldn't do as easily back when it was all done with photography tricks and things like that. Personal problems. Sometimes you're depressed, you're stressed, your wife is about to leave you, your husband's about to leave you, or whatever. You need to get this paper out or whatever. So then there are cultural differences. I pointed out that different countries have different pressures, different thoughts about different things, and probably a few other reasons why misconduct occurs. I can't actually read. You can see it's retractions are going up. Retractions are on the rise. These are ones that were done from mistakes. These are ones that were done from fraud. So similar numbers between fraud and bad science, and then other. I don't know what other would be. But this comes from the New York Times. So people read about this, and it's not good for us as scientists, for the general public to read about misconduct in science. So let's go through a few case studies. Here's one. Informed consent documents, which is when you're doing human subjects, contain multiple places for a participant to sign. Audit of the study revealed that some of the signed informed consent signatures on one part of the form did not match signatures on another part of the form. Some signatures appeared to be forged. Was this research misconduct? I think many of us would think so. But when this case was looked at, it was not considered misconduct, because even though it was non-compliance with the federal regulation, on the weight of it, it was determined that it was not material failure. So somebody just took a little bit of a shortcut or something like that, and that they didn't falsify the data or the plagiarism. It was considered a serious case of non-compliance, and that can get you in trouble in a trial as well and get your trial shut down, but it was not considered misconduct for that particular person. Study 2, graduate student includes falsified or fabricated data in 2 poster presentations, several lab meetings, and progress reports associated with federal grants. Is it misconduct? Absolutely. Okay, the one that makes it really bad is the federal grant. But when you're presenting data at a poster presentation, that's out there in the public as well. So this was a student. I hope nobody knows Brandy Blaylock, a former grad student at Wake Forest, knowingly did all of that involving an NIH grant. They reported that 12 non-human primates responded to anti-abuse. Compounds were never given to the primates. So it was complete fabrication. They received 3 years of probation in 2015. So under probation, that meant for 3 years, somebody had to oversee anything that had to do with their work on federal grants. To tell you the truth, that's a pretty mild slap on the hand for completely fabricating data. Here, a faculty member is developing personalized cancer treatments, published his results, and performed human clinical trials based on some falsified microarray data. Is this research misconduct? Absolutely. In this case, this particular faculty member at Duke was performing the research. He did it to embellish his resume. It resulted in 27 papers being retracted, and the termination of an ongoing clinical trial. He neither admitted nor denied the findings. He was stuck on supervised research for 5 years, and the university had to repay the grants. Okay, again, I think this is a fairly mild punishment for actually exposing human subjects to what may not have been a properly designed trial. This is another one I wanted to show because it's one I've seen a couple times. Sabotage. This is a grad student at the University of Michigan suddenly has a series of experiments on cancer research go awry. Okay, we won't go into the details of it, but basically, and cell cultures died, everything was going wrong for this student. The same assays performed in another lab all worked. Okay, so the student went to the PI who took it to the Office of Regular Affairs. They put cameras up in the lab, and they found that a postdoc in the lab was purposely sabotaging experiments. I actually went on sabbatical at Harvard a couple decades ago, and an event just like this had happened in the laboratory just before this. The postdoc claimed it was just under intense pressure. I'm not sure what the pressure was to compete or to be as good as everybody else in the lab. He was prosecuted. The judge sent him to repay a few thousand for the reagents and court fees, put him on probation for 6 months and 40 hours of community service. The PI prepared a detailed list of damages that led up to about $72,000, and somewhere there was a settlement with that postdoc, somewhere in between there. Okay, so you notice we had an example where one guy went to jail. People have to pay back money. There can be serious consequences. This is one that's dear to my heart. You guys have already, and I'll only mention it briefly because you've already had the foreign influence on science. But this is the case where a bunch of investigators at the Moffitt Cancer Center were found to be involved with a Chinese, what was it, 10,000 Talents program or something like that. And, you know, there's nothing wrong. These 6 cancer researchers ended up being dismissed. It involved the cancer center director who was somebody I know quite well. And he may have just gotten caught up in it, but he did a couple things wrong, and he paid the price of a very successful career being stalled out completely. And it wasn't that they did anything wrong by being part of this program. It's that they failed to tell Moffitt that they were part of this program. Okay, and so that creates a conflict of interest, or the potential conflict of interest, that they're doing work with a foreign entity or another university or another company or any of those things, and they didn't tell their university about it. So the one lesson from this and many other things I've seen is always be forward about any potential conflicts of interest you have. Always tell your institution anything where you're involved with science outside of that university. And as long as you tell them about it, most of the time you'll stay out of trouble, as long as you don't do something really bad. Here's another one I added because I think it's so important to today's world. The MMR, measles, mumps, rubella vaccine in autism. I think most of you know, at least indirectly, of this 1998 paper by Wakefield. This is in Britain, that showed a connection between MMR and autism-like spectrum disease. It made a huge impact, all kinds of, it made people stop vaccinating their kids in many, many countries. In 2004, it was uncovered that a lot of the data was faked. And there was at least a partial retraction of the paper. And it wasn't until 2010 that they discovered that everything was completely fake. The data were not real at all. And the paper was completely retracted. Wakefield lost his license to practice medicine. I think he may have had some worse things too. But for me, the important thing is vaccination rates plummeted in many, many countries. And quite frankly, I think most of you recognize that this paper is used by anti-vaxxers as the main, is still used by anti-vaxxers as the main reason not to vaccinate. In a world where we could use a COVID vaccine and where we still need people to put their kids on MMR, this was a major societal disruption that a misconduct caused. I also wanted to bring up that COVID-19 has created its own pressures. Everybody wants to do really rapid COVID research. We've had some really nice papers come out of Tulane related to COVID-19. It's an opportunity, but it's also making people move really fast. And this can put some pressure on it. You have to think about these pressures, of whether there's pressure to approve a vaccine, pressure to approve a drug, pressure to put any of these things that is not appropriate. And of course, as long as you're not faking the data, as long as you're doing it above, there's nothing wrong with it. But I will tell you that there's an alarming retraction rate of these papers, okay? I'm a woodworker, and so, the go fast, go twice rule in terms of cutting wood is a standard where you make mistakes when you go too fast. So there's always a careful balance between moving really fast, and it's not just the scientists that are moving fast, the review process wants to go fast because journals want to publish these papers, and so there's pressure on the reviewers and on the editors to get things out. So keep those kinds of things in mind. So what lessons have we learned from any of this? Any person involved in research, it can be a technician, it can be a grad student, a postdoc, a PI, anybody who's tied to that research can be responsible for the misconduct. In fact, the majority of people getting in trouble have been more at the technical level and not the doctoral degree holders, apparently. Usually the excuse is either excessive workloads, time pressure, or other pressures. Well, also, I'm going to bring up the concept of scientific divorces, which is any time a scientific collaboration, relationship, or whatever goes south, it can lead to recriminations. Sometimes this is often when accusations of misconduct come about, either both appropriately and inappropriately. In fact, I thought you guys would get a kick out of this one. I don't know if you guys remember the 60 Minutes covered a Tulane faculty member who tragically died in a car accident, but one of his past people said he faked his death and that of his wife in order to avoid fraud charges that the guy was bringing up. And they'd clearly gone south in their relationship. So what is the impact? For one, a university's reputation can really be hurt. And the best thing a university can do is to make sure that if there's any hint of fraud or misconduct, that they look into it thoroughly and come to the right conclusions. There can be all kinds of harm to employees, research subjects, students, or trainees, both career harm, money harm, physical harm. You can often force extra oversight in terms of doing, in terms of your personal research, your programs, and your institution. Some researchers get suspended for periods of time or even for life. And there can be fines, penalties, and even, in some cases, jail. So, just to finish off, let's talk about Tulane. First of all, the faculty handbook has a listing of all the, and the website has a listing of all of the rules and procedures. If you discover or even suspect research misconduct, you should approach the compliance officer for guidance. You can do this anonymously, or you can just ask them to protect you, which they will, and that would be, Lisa and Brian or Piedemonte. If you're accused of research misconduct, you are entitled to due process, and so you should work again with the compliance officers to make sure that that everything's handled properly. And again, they're obligated to do the best they can to protect confidentiality. So stages: submission of an allegation, assessment by the Office of Research Integrity or the research compliance. At that point, any questionable data, information, and so on will be collected. Okay, notebooks, all that sort of stuff, to make sure that nothing can be changed or lost or whatever. And then an inquiry begins if all these previous steps, and then there's an investigation. The investigating committee puts together a formal finding, which with recommendations, which then ultimately go to the NIH office for approval. This all can take a long time. It's very disruptive for everybody involved because you spend hours and hours getting the data into the right form. I'll tell you, keeping good notebooks and keeping your data well it can really help this process. It's always good if an informal resolution, for instance, if it's a question of whether you think somebody's misused some of your own data or something like that, you might be able to work it out. So try to work it out. But if you have to submit an allegation, and it will go through the formal process, and if it involves the PHS funding, that they will have to approve the decision. There may be a letter of reprimand in somebody's permanent record. You can shut down the particular project. There can be monitoring and future work by scientists caught for this. There's suspension or expulsion in terms of students. There's termination of employment for staff and for faculty. Well, and for dismissal of the faculty member. Disciplinary actions by the sponsor. They can restrict besides the letter of reprimand, they can restrict expenditures. They can terminate the award. They can require that publications and any other research record get fixed. They can prohibit individuals from moving forward on any federal agency again. And they can even, if it's bad enough, if the institution is found at fault at all, they might even consider punishments to the institution. So if you have any questions about anything like this, you're certainly welcome to contact me. But the University Research Compliance officers, Lisa Wurtzel and Brian Weimer, all their contact information, feel free to do that. I've seen cases where people in their field just saw the same figure appear in multiple publications or whatever, and report it. You can report things to journals when you see something wrong as well, if it's not in your own institution. But anyway, these are the processes. The best thing is do good science, do it ethically. I also want to mention that some of this stuff, for instance, many of us review grants. People put their ideas in grants. It's very critical that if you're exposed to other people's ideas, that you not act on them inappropriately or pass those ideas on to other people, for instance. There's a lot of places where plagiarism and appropriation of ideas and so on can come into play. And it's always worth looking at, thinking, should I be talking about this to somebody else? Okay. And that sort of thing, and to keep it a high standard. I think that's it for the, yes, it is. Thank you. I'm happy to take questions.
Thank you, Dr. Deininger. If anybody have questions, you can unmute yourself or you can put the questions in the chat. No questions?
Okay. Then we have a bunch of very ethical scientists all ready to be great. I look forward to getting back to in-person discussions of these things.
Indeed. All right, well, if we don't have any questions, Dr. Downing, we thank you so much for your wonderful presentation, and we will see everyone back next week.
Good deal.
Bye, everyone.